Okay, today we are going to study about how to find the solution of algebraic and transcendental equation by regular falsy method. It requires intermediate value property theorem. If it is stated as if f of x is continuous in the interval a b, and if f of a and f of b are of opposite signs, then the equation of f of x equal to 0 will have at least one real root between a and b. For example, f of x equal to x cube minus 3x minus 1 equal to 0. At x equal to 0, f of 0 is minus 1, it is negative. At x equal to 1, f of 1 is minus 3, it is also negative. At x equal to 2, f of 2 is a 1, it is a positive. Here the sign of f of 1 and f of 2 are of opposite signs, so the root lies between 1 and 2. This theorem is called as intermediate theorem, and it is required to find a root of a given equation by regular falsy method. Now, what is the formula of regular falsy method? Consider the equation f of x equal to 0 and a having coordinate a comma f of a and b is a point having coordinate b comma f of a are 2 points on the curve y equal to f of x such that f of a and f of b are of opposite signs. The curve meets x-axis at a point C having coordinate x comma 0. The value of x at point C is the exact solution of the given equation fx equal to 0. But here we have to find a solution closer to exact solution by regular falsy method. See the diagram or figure shown. Here the curve is shown and the curve intersect x-axis at point C0 and A is one point, B is another point on a curve. Join the point A and B, we get a chord AB and it intersects the x-axis at point D having coordinate x1, 0. The equation of a chord AB is y minus f of a upon x minus a is equal to f of a minus f of b upon a minus b by using 2-point formula. The equation, the point D x1, 0 lies on this chord, so we put x equal to x1 and y equal to 0. We get x1 equal to a into f of b minus b into f of a upon f of b minus f of a. This value of x1 gives the first approximate root or solution of the given equation f of x equal to 0. If f of x1 equal to 0, then x1 is a root, then stop. Otherwise, the root lies between a and x1 or x1 and b according as sign of f of x1. If f of x1 and f of a are of opposite signs, then the root x2 lies between x1 and a. Hence, the second approximation to root is x2 equal to a into f of x1 minus x1 into f of a upon f of x1 minus f of a. This is the second approximation to the root which is a better than value of x1, or it is a closer to the exact root than a value of x1. Continue in same way, we get a third approximation x3, then next fourth approximation x4 and so on. Example, solve for positive real root of equation x minus cos x equal to 0 by regular falsy method up to 4 approximations. So let f of x equal to x minus cos x. This is the given equation. Now we have to find out an interval where the root of this equation lies. For that, we have to use intermediate value property. first value of x equal to 0, then find out value of function, that is f of 0 is equal to -1 we get. It is a negative. The next value of x we can choose as x equal to 1, then f of 1 equal to plus 0.4596 positive. The next value of x 2, then f of 2 is increases positively. So here the sign of f of 0 and f of 1 are of opposite sign, so root lies between 0 and 1. We get at least one root between 0 and 1. Here a denoted by a is 0 and b equal to 1. By regular-Falsy formula, the first approximation x1 equal to a into f of b minus b into f of a upon f of b minus f of a. Put the value of a, f of a, b and f of b, we get x1 is equal to 0.685078. It is the first approximation to the root of a given equation. Now for proceeding second approximation, first we find the value of function at this new root x1. We get that value minus 0.089292. It is also negative, but f of 1 is a positive, so that root lies between 0.685078, it is x1, and 1. Then the second approximation to the root x2 by regular-Falsy method, x2 equal to 0.685078 into value of f of 1 minus 1 into value of f of 0.685078 upon f of 1 minus f of 0.685078. This gives x2 equal to 0.736299. Again find the value of function at x2, and it is we get minus 0.00466. It is also negative. So for next approximation, the root lies between 0.736299 and 1. Then again using regular-Falsy formula for this new interval, we get a third approximation to the root x3 equal to 0.738945. Proceeding in same way, we get a value of root or approximate root at the fourth approximation, x4 equal to 0.739079. At fourth approximation, the required solution is x equal to 0.7391 correct to 4 decimal places. This is the answer to the given question at fourth approximation by regular-Falsy method. Here we note that at every approximation we are reducing the length of interval by a factor 1.62, so that in general we can say that rate of convergence of regular-Falsy method is 1.62. Hence, thank you.